A pleasant day, everyone. Welcome once again to our discussion for today. Today class, we are going to wrap up everything, about the topic of derivatives of algebraic functions. Just to give a short recap of what we had so far. Now let us look at the objectives of this lecture. Since the beginning of our discussion on this topic, derivatives of algebraic functions. So as you can see from the objectives, so far we have done already some of them, and now we are going to complete the topic, starting from this part. Now, so far we have already done this interpretation of the concept of derivatives. So we used the geometric presentation of our discussion last time, and then we used the derivative to find the slope of the curve. So we have this already. And we also have in our example of finding the equation of the tangent and normal lines. So we have done this so far. Then this time, up to the end of this topic, so we are going to discuss this part here. Apply the rules on differentiation to find the derivative of algebraic functions, and apply the product and quotient rules in differentiating functions, and then apply the chain rule in differentiating functions. Then later on we will go back to the slope for more detailed discussions and also the application of that part of the discussion. Okay, so we'll start with the differentiation rules. So derivative of algebraic functions. So we have here the derivative of constant function. Okay, so what does it mean? So we have here a theorem number 1, that if a function of x is equal to k, where k is a constant, then we have the derivative of the function of x is equal to 0. Okay, so derivative of a constant, in short, derivative of a constant is equal to 0. That's theorem number 1. For example, if you are given, say, f of x equal to 5, then you are asked to find or evaluate the derivative of 5. So the derivative of 5, represented very simple, is equal to 0. Or if you have a function of x equal to minus 3, then the derivative of this minus 3, which is constant, is also equal to 0. Okay, so that's theorem number 1. Then we have another power rule here in theorem number 2. We call it power rule. So theorem number 2 says that if f of x is equal to x to the power n, where n is any real number, then the derivative of this x to the power n is equivalent to n times x to the power n minus 1. So the theorem number 2, we have to make, when you find the derivative of this function in this form, you have to bring this exponent down and then multiply it with a base, and then the exponent will be that exponent minus 1. So we have the derivative of x equal to n times x to the power n minus 1. So that's theorem number 2. For example, if you're given f of x equal to x cubed, then the derivative of x cubed is simply, so bring the exponent down, multiply it with the base, which is x, so and then the exponent will be minus 1. So we have therefore 3x raised to power 3 minus 1, or equal to 3x squared. Then another example, if you have another function of x equal to x to the 4th power, then the derivative of that function is equal to, so you have to bring this down, which is 4, and then the exponent now subtract by 1. So therefore we have 4x cubed. So that is the derivative of these two functions. Okay, that's all for theorem number 2. Then we have what we call constant multiple rule. So this is our theorem number 3. So it says that if the function of x equal to constant multiplied by a function of x where k is any constant, it can be positive number, it can be a negative number, it can be a fraction, it can be a whole number, it can be a decimal, so any constant, then the derivative of x is equal to the constant multiplied by the derivative of that function. For example, if you're given, say, function of x equal to 4x cubed, so we have here the constant 4. So what we're going to do is just isolate this constant and then take the derivative of the variable. Oh, this time, class, we will use another symbol. We have d, then we have a subscript here, x. So it means that derivative of x, derivative of x cubed with respect to x. Alright? So this can be written as in the rule, it says that constant multiplied by the derivative. So you just isolate the constant, then take the derivative of the given function, x cubed. So applying the previous rule or previous theorem, power rule, so the 3 will go down and then multiply it to the base. The numerator, the exponent is minus 1, or the 3 minus 1. Whatever is the exponent, you just subtract it by 1. So that will be the new exponent. So we have 4 times 3, 12. Then the exponent now is 2. 3 minus 1 equal to 2. So therefore, we have 12x squared. Another example, if you have, say, another function of x equal to 5x squared, then the derivative of this function, so you just isolate this constant, then take the derivative of x squared, then applying the power rule. So we have 5 times, applying the power rule, you have 2x squared raised to the power 2 minus 1. So multiply this 2, so that is 10. Then here, x to the power 2 minus 1, that would be x to the power 1, or simply don't write the power 1, no? That's understood to be power 1, the x here. So therefore the answer is 10 times x, or 10x. Then we have also the sum rule. So what does it mean, sum rule? So this is our theorem number 4, that if you have function of x equal to g sub x plus or minus h sub x, then the derivative of the function is just the sum of the individual derivative of different functions, sum or difference. Alright? For example, if you are given, say, if f of x equal to x cubed plus 3, then f prime of x, or the derivative of x, equal to 3x squared. So using rule number 3 here. Then plus derivative of constant is 0, so you have 3x squared. Then that one, g sub x equal to x squared minus x. Then the derivative of this function here, g sub x, equal to, so applying the theorem number 3 and theorem number, the power rule. So this one will go down, then multiply the base, then the power becomes 1 less, so 4 minus 1. So therefore, then minus derivative of x with respect to x is equal to 1. Okay, so this is the solution here is 1. Then because this is understood to be, or to have 1, that is the power 1, so 1 will go down, then the power 1 minus 1 becomes 0. But any number raised to power 0 is equal to 1. That's why 1 times 1, you have 1 here. Okay, so is that clear? So next we have derivative of functions, algebraic functions. So we've done this one, theorem number 4. So next is we have here the sum rule. Before we have, or a while ago, we have the sum rule theorem number 4, but here we have the theorem number 5. Okay, so theorem number 5 is that if you have so many terms here, you're different, or a lot of functions, and you're adding all those functions. So we have here the general formula. No? If theorem number 5, if function of x equal to uh, function of x plus or minus f1 of x plus or minus f2 of x plus and minus and so on and so forth until you have f of n sub x. Then the derivative of this functions, the sum of or difference of these functions is simply f1 f1 prime of x plus and minus f prime uh, sub x f2 prime sub x plus and so on and so forth plus f prime n sub x. Okay, so this is the generalized sum rule, no, for more than two functions that are being added. Okay, so that's theorem number 5. For example, if you have, say, if f of x equal to x cubed plus x squared minus 5, then f prime of x, so you just take the derivative of each of this term here. Okay, so derivative of x cubed, so you have 3x squared. Derivative of x squared, that is 2x. Derivative of constant, uh, that is 0. Alright, so therefore, the derivative of the function x cubed plus x squared minus 5 is simply equal to 3x squared plus 2x. So our final answer here is 3x so this is 3x squared 3x squared 3x squared plus 2x. Okay, so next we have general power rule. So if u is a differentiable function of x, then we have, okay, so another formula. So this is we'll use the other symbol of the derivative. So the derivative of u to the power n with respect to x equal to n times u to the power n minus 1 times the derivative of u with respect to x. So this is what we call general power rule. Okay, for example, if you're given, say, f of x equal to 6x plus 3, then everything, this quantity here is raised to power 4. Then the derivative of it, so applying this one, so our u here is equal to 6x plus 3, then our n is equal to 4. Okay, so applying this, you have n, which is 4, then multiplied it by 6x plus 3, then the power or the exponent now is n minus 1 or 4 minus 1. Okay, then the derivative of u with respect to x, so our u is 6x plus 3, so take the derivative of it with respect to x, so therefore we have 4 times 6x plus 3 raised to power 3. So 3 here is coming from 4 minus 1. And then take the derivative of this part here with respect to x. So that is equal to 6. So combining, we have 4 times 6 is 24. Multiplied by 6x plus 3 raised to power 3. Okay, so that's the general power rule. Then another example here, if you are given radical, a function that is expressed in radical. So for example, if y equal to the square root of x cubed plus 4x, then we rewrite the radical in rational exponent form, something like this, because the index here is 2. You didn't see any number here. This is understood to be 2, the index of the radical here. So therefore, converting this or writing this into radical in rational form, so we have y equal to x quantity x cubed plus 4x raised to power 1 half. So taking the derivative, so we are given here y, so you have to write it y prime equal to 1 half, no? Applying the uh, general power rule here. So you have n is 1 half. So the power will go down, multiply it with the base. So 1 half times x cubed plus 4x raised to power 1 half minus 1. Because the rule is n minus 1. So our n is 1 half, so minus 1. Then multiplied by the derivative of u. So this will be our u here. So derivative of it, derivative of x cubed plus 4x. Then Going forward, so we have 1 half x cubed. So this 1 half is coming from the exponent. Bring it down, multiply it with the base, then the exponent would be subtracted by 1. So that's why we have here negative 1 half, because 1 half minus 1 is negative 1 half. Multiplied by, so derivative of this one, x cubed plus 4x is simply 3x squared plus 4. So finally we have, just multiply the numerators, multiply the denominators. Okay, so this can be brought down because the exponent here is negative, right? If you have, say, x to the power minus m, so we can rewrite this as 1 over, or 1 divided by x to the power m. Alright, so this is what we are using in this part here. So negative, the exponent here is negative. So bring this down and then make it positive. Okay, so this will be, it would look like this, but raised to power 1 half. But you know that 1 half, if the index is 1 half, that means square root. So you change that. Supposedly this is, or this is a power 1 half. But that means that the index is 2, so you have the square root of x cubed plus 4x, then multiplied by 2. Okay, so that's an example of, for example, for theorem number 5. That is the general power rule, application of general power rule. Now we have here some exercises which I would like to ask you to solve them. Here for number 1, so that is the sum or difference of functions. So when you take the derivative, you have to take individually for this one. So derivative of x to the 5th power, that is a power rule, that is 5x to the 4th. This one, so bring this 2 down, multiplied by 3, multiplied by x, so we have 6x. So power is 2 minus 1, so 1. So no need to write the exponent here if that is understood to be 1. Okay, so derivative of a constant is 0. Alright, so you just do the rest class using the theorem. And later on, perhaps in the next video, I will show some examples of all these differentiation rules. So the instruction here is to find the derivative of the following functions. Now recall that the constant function rule is something like this, that the derivative of f of x is, if f of x is equal to constant, then the derivative of that constant is equal to 0. Then derivative of e plus pi. So e is a constant, pi is a constant. So when you add them, when you take the derivative, this is constant. E is constant, equal to 2.7182818. Then pi is equal to 3.1416. So it means that the derivative of e is 0, derivative of pi is 0. So 0 plus 0 is equal to 0. So that is our derivative. Okay, and then recall also from the power formula, we have function of x equal to x squared. So the f prime of x is simply 2x. So just bring it down, the exponent, bring it down, and then multiply by the base, that is 2x. Then power is 2 minus 1, understood to be 1, so no need to write it here. So f prime of x, or the derivative of x, equal to 2x. Another example, if you have f of x equal to x cubed, so the derivative of this function is simply 3x squared. So power formula. So this time class, we can use this technique using the differentiation rules in finding the derivative. So it will take a very short time class compared to the previous method, the long method, where you use the limit. Okay. Then recall also that they have some limitations of our formula. So be careful, because you might wrongly interpret the formulas or the rules. Like for example, if you have a function of x equal to square root of x cubed, so how will you find the derivative of this function? So take note, class, that this is not equivalent to this. That is not equivalent. So be careful. So this is not equal. So what you did, the power formula inside the radical, you cannot apply that one. Okay? You cannot use that power formula if the number or the term is enclosed or inside the radical symbol. Then if you have f of x equal to x to the power 3 halves, so this is equivalent to, still the power is 3 halves, you bring it down, multiply by x, so 3 halves x, then x raised up by 3 halves minus 1. So 3 halves minus 1 is equal to 1 half. So that's why we have here power 1 half. Okay, so any question, class? So I hope it's all clear to you. Then recall also that another limitation is something like this, that if you're given a function of x equal to 1 divided by x cubed, this is not equivalent to 1 over, then you apply the power rule. So this is very wrong. So be careful on this. This is not the right answer. It's not the right solution. So we have a solution for that. So you have to bring it up, make this is positive, the exponent here positive 3. So when you bring this up, that will become this is positive. When you bring this up, this will become negative. Okay, so this becomes 3x minus 4. That is or equal to 3 divided by x over 4. You just bring it down. Okay, so that's example of this fractional function, and we have learned that there are some steps that is not right, something like this, so it's a wrong move. Okay, so another one for sum rule, you are given function of x equal to x cubed plus x squared. So the answer is, so when you take the derivative, so derivative of x cubed is 3x squared, derivative of 2x is, derivative of x cubed equal to 3x squared, derivative of x squared is simply 2x. So in other words, class, you are applying the sum rule here. We have two terms. You just take the derivative of each of the term with respect to x. So derivative of x cubed using power rule, so that is 3x squared plus derivative of this can also be or you can use also the power rule here, so that is equivalent to 2x. Okay, now we have another one, function of x equal to x to the 4th plus x squared plus 3x. So we can just do the same. So for our first term of our answer, that is the derivative of x, so the first term is 4x cubed, the second term is 2x, the third term is 3. So derivative of x with respect to, or the derivative with respect to x is equal to 4x cubed plus 2x plus 3. Then recall also for our sum rule, we have f of x equal to x cubed times 2x plus 5. So one way of doing it is to distribute and multiply. You distribute and multiply this one, so you will have this. Okay? So what's the answer? So the answer is, this is not the answer, this one. This is wrong. This is wrong. So what is the correct answer? So the correct answer is something like this. You distribute and multiply. So x cubed plus 2x, that would be 2x to the 4th. X cubed times 5 equal to 5x cubed. Okay, now from there, you can take the derivative. So the derivative of the first term is, so that would be 8x cubed. Then here, plus, so 8x cubed plus derivative of this is 15. This will go down, times 5 is 15. Then the exponent become 1 less, so 15x squared. Okay, so the best way to solve this problem is to distribute and multiply before you perform the or get the derivative. Okay, so you multiply this, x cubed times 2x, so you have 2x to the fourth. Then x cubed times 5, so we have 5x cubed. So this time you take the derivative. So taking the derivative, so we have for the first term, we have 8x cubed, and the second term is 15x squared. Okay, so any question? So recall for the sum rule, once again we have this, but this time is fractional, but we can do something, no? You can first factor. By the way, you cannot do it like this, huh? This is another wrong way of doing things. So this one, okay, it seems it follows the rule, but if you say like this, so this is not the correct solution, class. So the correct solution is, you have to perform, if you look at the numerator, there's a common, that is x squared, right? Then factor out common, then you have x squared at the denominator, so you have x squared here as the factor. So you just divide, no? We have x squared divided by x squared, so equal to 1. So you have left 4, x squared is gone, so it will become 4x. Okay, here we have 2x squared divided by x squared, so 2, right? So it's just like you're dividing, huh? You're dividing each term by x squared. So this one divided by x squared, so that is 4x. This second term divided by x squared, so we have 2. So that's the time that you can perform the operation, no? This is sum rule. So to take the first derivative, you have to take the derivative of each part, of each term individually. Okay, so therefore derivative of 4x is equal to 4, derivative constant is equal to 0. So that's why we have a final answer is equal to 4. Now we have product rule. So what is product rule? If you have f of x equal to the product of g sub x and h sub x, okay, so the function of x is the product of two function of x. So then you have the following rule. So f prime of x, or the derivative of x, equal to g sub x. So you just copy this one, okay, then multiplied by the derivative of h sub x, okay, then plus. So this time you have to write first h. So a while ago we write j or g. Now next is h. So plus h sub x, okay, this one, this part, multiplied by g prime of x. So for example, if you're given, say, f of x equal to x cubed plus 3, so quantity x cubed plus 3 multiplied by quantity x squared plus 5. Okay, so apply that formula. So this one you just copy this part, then take the derivative of the second part, okay, then plus second part, then derivative of the first part. Okay, so uh, evaluating, we have the quantity x cubed plus 3. So this becomes 0 here because derivative of a constant is 0. Okay, then plus this one, this term here, and derivative of this. So derivative of this will be 3x squared, then plus derivative of a constant is 0. Okay, so rewriting, we have the quantity x cubed plus 3 multiplied by 2x, then plus the quantity x squared plus 5 multiplied by 3x squared. Okay, so you may stop up to this part, or you may continue evaluating this one. You can distribute and multiply, and then combine similar terms, and then you will get the final result. Okay, so in your case, I want you to simplify this one. So to do that, you have to multiply 2x individually, okay, for this quantity here. Then also, after that, this one also, you can multiply its term. Okay, so what's the result? So this will be 6x cubed. Okay, so you just continue this one, class. Um, so this will be 6x to the fourth. 6x to the fourth, then plus 6x. You can remove the sign of grouping. Then plus, that is x to the fourth. Then you have this one multiplied by 5. So plus 15x squared. Okay, then combining similar terms. So we have 6x to the fourth. We have 1x to the fourth. So this would be 7. 7x to the fourth. Then plus 6. Sorry, that is 3. So this would be 3x. Okay, so 6x to the fourth plus sorry, this is 6x. Okay, so this one, that is 6x to the fourth. This one is 6x, then plus, this is multiply, we have 3x to the fourth. Okay, let's multiply this one, so 3x to the fourth plus, should be 15x squared. Okay, so we have 3x to the fourth. Sorry, just okay, so what's the final answer here? So we have 6x to the fourth plus 3x to the fourth. So combining them, we have 9 x to the fourth, x to the fourth. Then we have start with next higher exponent, so 15x squared, then plus 6x. Okay, so you may stop up to this part, or you can still factor out common and then express it in another expression, or you can stop up to this part here. Okay, so that's another example of what's this part here, this product rule. So if you're given this one, g sub x equal to 2x to the fourth plus 3x multiplied by the quantity 2x plus 1. So quantity 2x to the fourth plus 3x times quantity 2x minus 1. So just do the same, no? You just distribute this. Okay, so what you are going to do is this one. That is 2 times 2, that is 4. Okay, another way of doing it is something like this. That is, so this one becomes 4x to the fourth, 4x to the fifth. So this will be 4x to the fifth. Then when you multiply this, that is plus 6x squared. And then this one, multiply this one individually. So this is minus 2x to the fourth. And when you multiply this, so you have minus 3x. Okay, so you can combine similar terms, or in this case no similar terms, and then you take the derivative. So you take the derivative of this g prime of x, so you have to take the derivative of each term. So derivative of this is 20x to the fourth, and we start with this one. So derivative of this is minus 8x cubed, because this one goes down. So 2 times 4, 8. Then this one minus 1. So x cubed. So minus plus. This is plus 6x squared. So derivative of it is 12x. And derivative of 3x is equal to 3. Okay, so this is our g sub g prime sub x. Using uh, the other method class. So that's your answer. Okay, now if you use the formula, so copy. Now the formula says that you just copy this one. Okay, and after that, derivative of this, the derivative of this is 2 minus 0. Then plus this one, okay, times the derivative of this one. Okay, so you have 2, then applying the power formula, so this becomes 4x cubed. No, the 4 here will go down, then multiplied by the base. Then you have 2, which is the constant. Okay, so equal plus derivative of 3x is 3. Okay, so let's see if we can obtain the same result. So this one, you have multiply this, so we have 4x to the fifth, no, 4 to the power 4. Sorry, this 4 to the power 4. Then this one plus 6x. Then plus, so now you have to combine this one. So we have 2x minus 1. Then this has to be multiplied. This one here, this would be 8x cubed. Then plus 3. Plus 3. Okay, and then you can multiply each term here with each term of the secant quantity. Secant term to each. Right, so we have 4x to the fourth. Then plus 6x. So when you distribute and multiply, so 2x plus 8x cubed. 2x plus 8x cubed. So this would be plus 8x cubed. And this one 2x cubed plus, so this is 6, sorry, that's 6x cubed. Okay, so 4, this is 16. Sorry class, this is 16. Okay, so this is 2x times 8x cubed, so this would be 16. 16x to the third power. And this one multiplied by, this is 2x times 3, that is 6x. Then negative 1 times positive 8x. So this would be minus 8x cubed. Then minus 3. Okay, this combining similar terms. We have here 4x to the fourth. Okay, and then we have this one combined with this. So this one is just alone. Is it alone? 16, sorry. So this is 16 to the fourth. Sorry for that class. So this should be 16 to the fourth. Because 2x multiplied by 8x cubed, so you add exponents of the 2. So this is 16 to the fourth. Okay, so where is this part here? Okay, and then So combining this one, we have positive 6x, and we have another positive 6x here. Okay, and then rewriting and arranging them. So we have 4x to the fourth plus 16x to the fourth, so that would be 20x to the fourth. Then next, followed by a term that has the next power, which is 3, so that would be minus 8x cubed. Then you have 6x here, so 6x plus 6x, so that would be plus 12x. Then minus 3. Okay, so this is our answer. So if you look at this answer, class, and compare it with the answer above using the other method, so they are just the same. So this is also our g sub x. Alright. Okay, so next we have so if you're given something like this, then we have, you just copy the first term, first part here, this factor, copy and then take the derivative of the second factor. Okay, then plus copy this, okay, and then derivative of the first factor. Then evaluating, you have this. If you reach your answer, class, up to this point, you already have the point. Now, if you're asked to show all the steps, but the final answer here should be shorter because, or if you can still expand this one, but the problem here, the exponent is a very huge already, so perhaps it's not easy to present this in another manner. So just you can stop up to this part here. But the problem is if you have multiple choices, here, then the answer, you might not be seeing this one because maybe the final answer was simplified. Then that's the problem, no? So you should know how to expand this one and then simplify. So you can use the Pascal triangle here to expand this one and then perform the operation. Okay. Alright, so for the quotient rule, so if you have this function of x equal to g sub x divided by h sub x, so we have here the rule. The rule is that you have to copy the denominator, okay, and then multiplied by the product of the, multiplied by the derivative of the numerator. Okay, we have g prime of x minus the numerator. Okay, just copy that one, and then multiplied by the derivative of this, and all this, the numerator divided by h sub x squared. Okay, you have to square the denominator, no, for this. So this is the quotient rule. So we have to use this formula when evaluating fractional function. Okay, for example, if you're given f of x equal to 2x plus 3 divided by 5x plus 1. Okay, so applying that rule, you just copy this denominator. Alright, so copy the denominator and then take the derivative of the numerator. So derivative of this is 2. Derivative constant is 0. So that's why you have it here. Minus v. This one. You just copy this. You just copy this numerator. Okay. So minus, copy the numerator, then derivative of the denominator, which is derivative of 5x is 5, derivative of 1 is 0. And divided by, you square the denominator. Okay. Then simplifying. So you have this. Okay, and you can still simplify this further. You distribute here, right? Then distribute, so you have 10x. So if you're going to continue with this one, so you have 10x, 10x, then minus, sorry, plus 2, x plus 2, so you just distribute 2 and multiply. So 2 times 1 is 2. Then you also have to do this. For this one, this is minus, minus in close with the parenthesis, so this is 10x. 10x, 10x, then plus 15. So multiply this, so this is 15. So plus 15. Then divided by 5x plus 1 raised to power 2. Okay, and then you can combine when you remove this sign of grouping here. So 10x minus 10x 0. Then you have 2 minus 15, so 13. So this becomes 13 over 13 over 5x plus 1 and raised to power 2. Perhaps this is not clear, so I have to x plus. Okay, so that's it for the quotient. Another example is something like this. So same method class, you just take this one and then derivative of this, then minus this one, numerator, derivative of this, then everything divided by the denominator. Okay, so this is the process, but this is not really the final answer. You just do it yourself, what is the next step, and find the final result. Okay, so the next one is about chain rule. But before we discuss the chain rule, let us take this basic information yet. This about composite functions, because chain rule is applied for the composite functions. So what is composite functions? Or what is a composite function? So a function made of other functions where the output of one is the input to the other. For example, you have the functions 2x plus 3 and x squared together make the composite functions. So the composite function of this is just 2x plus 3 squared. So what does it mean? From this illustration class, we can say that this one, you just put it inside this x and then you square it, right? Because our first function is 2x plus 3. Our next function is x squared. So the process is that this will be our input to the next. Alright? So this would be, you substitute x here by this expression. So that's why we have it here. And then your x is being squared, so you also have to square that one. Okay? So composite function composition is applying one function to the result of other. So we have here function, say for example x, and then we have another function, say function of x also. So the result of f is sent through, so f is sent through g, okay, quantities, whatever it is, and it is written as, so if you have this result sent to or sent through g, so you have here g, then we have a small zero here, f of x. So this is the composite function of the variable x, which means that, so this presentation class means that g composite function of x, g sub f of x, g sub f of x. Okay, this is the one that we're going to use in our next differentiation rule, that is the chain rule. Okay, so further examples we have, if f of x equal to 2x plus 3 and g sub x equal to x squared, so x is just a placeholder. This is just a placeholder. So to avoid confusion, let's just call it input. Okay, so let's call it input. So f input equal to 2 input plus 3. Okay, so f input, you have 2 times your input is x, so 2 times the input plus 3. So g input is equal to input squared. Okay, so let's start now with the g composite function of x, g f, no? G composite f as a function of x equal to g sub f of x. So this is the meaning of this statement. So first we apply f. Okay, so first we apply f, then apply g to that result. So in diagram we have here x, then you have 2, then input, you have the input here, then plus 3. Then after that you come up with, so the result is 2x plus 3, right? Because you input x here, so you have 2 times the input. So 2 times the input, our input is x, okay, then plus 3. So what will now be the output? So the output is this input, which is this input of the second block, then this is squared. Alright, so in other words, you just input this one to the other, and we have the result 2 quantity 2x plus 3 squared. So because our input now is 2x, we have 2x, then plus 3. Okay, so you get it. So again, input x, you have 2 times the input, which is x, so 2x, then plus 3. So the output is 2x plus 3. Then you have now the input. So what is your input now is this one. So input it here, and then you squared it 1. So therefore you have 2x plus 3 then squared. Okay, so in symbol we have this g, then we have a small 0 here, and function of x, so equal to 2x plus 3 squared. Okay, so that's the representation class. So I hope you have able to follow looking at this diagram. What if we reverse the order of f and g? So if we look at the other slide, so we start with g, and here what if we reverse f and g? Will they give us the same result? Okay, so let us see. So if you have input x, so input x, so that become x squared. Okay, and then this will be your input, so 2 times input plus 3. Okay, so your input is x squared, so that will be 2x squared plus 3. Okay, so this is it. So we get a different result. So when we reverse the order, the result is rarely the same. So be careful which function comes first. Alright class, so that's about composite function. Now let's go to the chain rule. Okay, so the chain rule, if a function g is differentiable at a number x and a function f is differentiable at g sub x, then so this symbol f is not fog class, this f, then we have a small circle here, g. So it means that the composite function of f and g is differentiable at x, and in formula we have this symbol, Okay, so we have composite function of f and g prime. So function of x equal to f prime uh, function of x then multiplied by the derivative of the function of x. Okay, so it seems that this is confusing, so you have to listen carefully, and if you miss something here, you go back to the previous slides. So that explains everything. Alright, so that's the formula for the chain rule. We call it chain rule of differentiation. So for example, if you're given, say, f of x equal to x cubed, and you're given, say, g sub x equal to 2x plus 5. So now to get the derivative of the composite function, so we have the formula that f prime of g sub x multiplied by g sub x. So you just take this one. Okay, so take the derivative of this part, then multiply it by g prime of x, or derivative of g sub x. So this part here, we have 2. No? G sub x is 2x plus 5. So you substitute g sub x is 2x plus 5 from here. Alright, 2x plus 5. Okay, so where is this 3? So this 3 becomes, because you take the derivative, no? The derivative of this. In other words, class, in short, you just, in this case, we have written the f first, no, before g. So what you're going to do is you just change, no, to make it very simple and clear. What you're going to do is to just change, substitute g sub x here. Okay, so it means that you have, instead of writing x, your x is 2x plus 5. Okay, 2x plus 5. So 2x plus 5, because we have here f. Okay, so it looks like a function of f, a function of x, f sub x. So 2x plus 5. Okay, and then we know our f of x is x cubed. So this is our x, then raised to power 3. Okay, so raised to power 3. Alright, now when you take the derivative of this, so what will happen? When you take the, then we will combine the formula of the uh, general power rule. So general power rule, so apply, this is derivative. Okay, so derivative of this is simply power, general power rule. So general power rule, so it will go down. So you have 3, and then multiplied by the quantity. The quantity is everything here. So it is 2x plus, sorry, it's so slow. Okay, so 2x plus 5, and then derivative of 2x plus 5. So it means, class, after applying the power rule, okay, power rule, and then you take the derivative of the base. This is our base, this is our exponent, so the derivative of this is 2. Okay, so combining, so you have 3, you have 2, and then this is 3 originally. So using the power formula, so 3 minus 1, so we have 2 here as the power. Okay, then multiply this 2 and 3. So this is 6 times 2x plus 5. Okay, so you have this answer, or this is equivalent to you can distribute and multiply. So this would be 12x 12x plus 30. Okay, so this is our f. Okay, so this is the composite function of f and g as a function of x, which is equivalent to 12x plus 30. Okay, so that's it for the chain rule. So we have here another way of doing it. So if y is a differentiable function of u and u is a differentiable function of x, then we have this formula class that the derivative of y with respect to x, or dy over dx, is simply the product of the derivative of y with respect to u and the derivative of u with respect to x. So when you multiply, it's just like you have something here, you have something here, so this is just equal to 1, right? Okay, but don't do that, just an illustration that dy over dx for the chain rule is equivalent to dy over du times du over dx. Okay, so I hope this is clear. So we're about uh, to be finished. So for example, if you have, say, y equal to square root of u, then you have derivative of then you have u equal to x squared plus 1. So dy over dx, you just take the dy over du. So where is this taken from? So derivative of u is under the radical square root. Okay, so we know from our previous discussion, if you have square root of u, so the derivative of that is 1 over 2 times square root of u. Alright, and then times, so we apply here the general power rule. So we have 5x to the fourth. It means that from the formula we have dy over du, right? So du over dx. So you have to solve for dy over du and also the du over dx, and then you multiply the two. You will get the result. Okay, so something like this. The derivative of this is 1 over square root of 2u, 2 times square root of u, sorry, and then multiplied by 5x to the fourth. So this one is taken from the derivative of this. So derivative of x to the power 5 is equal to 5x to the fourth. Derivative of 1 is 0. Okay, so solving this further, we have 1 times 5x to the fourth, so 5x to the fourth, then 2 times square root of u, where u is equal to this, so you substitute the value of u here. So you have 5x to the fourth, sorry, this one, 5x to the fourth divided by 2 times square root of our u is x to the fifth plus 1. Okay, so that's our topic. So we end this topic here up to the chain rule, and in our next topic about the slope, so we are going to see again how the slope is being derived, and we will solve the same problems in finding the slope of the tangent line and normal lines and equation of the tangent line and normal line using this method. So we'll no longer use the long method. So we will use the differentiation rules in finding the derivative of the functions. Okay, so that's all for today, and hope uh, you were able to learn something from here. And see you again in our next video. So our next video will be once again about slope. Alright, so thank you very much. Stay safe always and stay healthy always. God bless. Bye bye.